Welcome to Chemistry with Mr. Brazil. I'm going to show you how to do a stoichiometric problem. There's a chemist mixed 0.71 grams of citric acid with 0.87 grams of baking soda in a 250 ml beaker. Nothing happened. The two powders do not react. After adding 50 milliliters of water, a reaction occurs, producing CO2, aqueous disodium citrate, and a little more water. After the reaction was completed and dehydrated, the chemist collected 0.73 grams disodium citrate. Now, when you see the word collected, produces, yield, forms, that's the actual yield. So this particular value, the 73, is AY. It is the actual yield that's collected in the lab. So remember that. That's going to be needed later. Okay, so now the question, what are the limiting reagent, theoretical yield, percent yield, and how much excess is left in the beaker? So let's tackle this problem. I teach my students to run both reactant masses to the desired product, in this case the disodium citrate. So we're going to write down 0.71 grams citric acid, C6H7O7. We're going to need to convert this into moles because the balanced equation is in terms of moles. So the molar mass is 192 grams HC6H7O7. And if you've forgotten how to get the molar mass, it's just 8 times 1 plus 6 times 12 for the mass of carbon plus 7 times 16 for oxygen. So grams per mole, that's what the molar mass units are. So let's write that down. Always label so that people can follow your math and there's no ambiguity. So parenthesis, fraction bar, whatever unit's on top, put it on the bottom. In this case, just so that you can see, the grams citric acid are gone. Now we're in terms of mole. So always write down your units and leave a little space for any value. So mole citric acid, C6H7O7. And we're going to convert this to the disodium citrate. That's this over here. And it's a 1-to-1 mole. So all balanced equations, the coefficients are in terms of mole. So 1 mole Na2 C6H6O7, parenthesis. And now we're going to mass this. We could stop at moles and we could determine our limiting reagent and our excess reagent, but we want to find out what's left in the beaker. So let's get some numerical value or a mass instead. So parenthesis, fraction bar, whatever unit's on top, put it on the bottom. Mole. Do not carry any numbers from the previous parenthesis, just the units. So disodium citrate N2, C6H6O7, and the molar mass of that is 236 grams Na, C6H6O7. And after putting this in the calculator, you will determine that it is 0.87 grams disodium citrate. Well, some students think, hey, we're here, we're done. No, we're not. This number doesn't mean anything. It just means that 0.71 grams of citric acid will produce 0.87 grams of the disodium citrate. Well, we got to run the other mass. So here's what I mean. We take the 0.87 grams baking soda, and now we convert this into the disodium citrate. So whatever unit's on top, put on the bottom, parenthesis, fraction bar, grams, Na, HCO3, that's the baking soda. And the molar mass of baking soda is 84 moles, Na, HCO3, parenthesis, fraction bar, and whatever unit's on top, put it on the bottom. And in this case, though, there are 2 moles. If you look at the balanced equation, there are 2 moles of baking soda to 1 mole of the disodium citrate. So write that down, AHCO3 to 1 mole Na2C6H6O7. And now I just copy the top because it's the molar mass. So that can be a little faster, 236 grams Na2C6H6O7. Let's put the unit below. No shortcuts. So again, whatever unit's on top, put it on the bottom. I did not change from that. So plugging this into our calculator, we're going to find out that this is 1.27 grams, or will produce 1.2. Did I say 27? I'm sorry, I meant 1.2 grams Na2C6H6O7. Now we have something here. We know that 0.87 grams of the baking soda will produce 1.2 grams. Well, what's in the beaker is 0.71 grams citric acid and the baking soda 0.87 grams. We're not going to get any more from the 0.71. So therefore, the smallest value is our theoretical yield. So this number is, if everything was ideal in a chemical reaction, no interference from other molecules or anything, theoretically we would produce only 0.87 grams of the disodium citrate. Also, with that information going to your left here, this is our limiting reagent. This is the limiting reagent, and the baking soda is what's in excess. Okay, so that's our excess reagent. Well, now we determine our limiting reagent, theoretical yield, and our excess reagent. Now we need to do percent yield. Well, percent yield, let's get a bit darker color. So percent yield is equal to AY over TY. And if you don't know which one goes on top, A is the first letter in the alphabet, therefore it should be on top, and T below. Make sure you write 100%. Okay, so this is the basic equation. To write it out, calculation is always theoretical yield. So 0.87 grams will go on the bottom, and then the 0.73 grams in the word problem it will go on top. That is our actual yield. So of disodium citrate that the chemist collected. So times 100%. Do not do any shortcuts. Show people what you're doing. And that is an 84% yield. Okay, so now we've got our percent yield. That's been determined. So how do we get our excess reagent? Well, here's what we do. Let me do that in red. So that's a little outside of the realm of the writing above. What we need to do is find out how much baking soda reacts with a 0.71 grams of citric acid. So to do that, we'll just convert it to baking soda. So 192 grams. So whatever unit's on top, put on the bottom. Yes, I repeat myself a lot, but that's to get people to actually physically do things. A lot of folks like to do shortcuts. So mole C6H7O7. Okay, now I go to the balanced equation. 1 mole HC6H7O7 reacts with 2 moles of baking soda, NaHCO3. Now, let's get the molar mass of this. 84 grams NaHCO3. And whatever units on top, put on the bottom. Notice I'm not carrying the 2 to the bottom. A lot of students like to carry values over. No, that 2's been used already. Okay, what this is going to give us is 0.62 grams of NaHCO3 baking soda. Okay, so 0.71 grams only requires 0.62 grams of baking soda. Now it's just real simple to find a subtraction. Take the 0.87 grams of baking soda and subtract the 62 grams of baking soda out, and you will have your excess mass, and in this case 0.25 grams baking soda is left over in the beaker. Ooh, I see an error that I did. Let's fix that real quick. Sorry about that. That was not meant to be intentional, but we'll fix it. So HCO3, CO3, so HCO3. And this is the excess mass in the beaker. And this is how we solve for everything in a stoichiometric problem. Repeat and watch this video if you don't understand how to do something. I find this method, running both masses, I mean, if we had 10 reactants, we'd run all 10, and yes, it'd be long, but at that point you use Excel or Google Sheets to do your math. But for high school and college chem, this is how we would do it. Run the two masses, find the smallest value, because that's your theoretical yield, which leads to the limiting reagent. From there, you can find your excess reagent. I would just convert the LR to the excess reagent and do the subtraction. All right, have fun studying, and chemistry, it's everywhere. Bye.